Ray tracing. Ray tracing is a graphics feature that makes lighting, reflections, and shadows look more realistic. Ray tracing enabled, the GPU simulates how light actually travels through a scene. For example, look at this puddle. Without ray tracing, the reflection looks fake or sometimes doesn't appear at all. But with ray tracing enabled, the puddle accurately reflects nearby lights and objects. The same thing happens with glass, mirrors, shiny floors, and even car paint. However, ray tracing is expensive. Turning it on can significantly reduce your FPS because the GPU has to perform many more lighting calculations. That's why many players only use it in single-player games where visual quality matters more than performance. DLSS. DLSS stands for Deep Learning Super Sampling. It's an AI-powered upscaling technology developed by NVIDIA. Here's how it works. Instead of rendering the game at full resolution, your GPU renders it at a lower resolution first. Then DLSS uses AI to reconstruct the image back to a higher resolution. For example, a game might internally render at 1440p but look close to 4K on your screen. The result? Higher FPS with surprisingly good image quality. DLSS is especially useful when using ray tracing or playing at high resolutions. However, because AI is doing some reconstruction, small visual artifacts can occasionally appear. Still, for many players, the performance boost is absolutely worth it. Path tracing. Path tracing is basically ray tracing taken to the next level. Instead of improving only specific reflections or shadows, path tracing calculates lighting across the entire scene. This creates much more realistic global illumination. Light can bounce naturally between walls, floors, objects, and surfaces. As a result, some games can look almost photorealistic. But there's a catch. Path tracing is one of the most demanding graphics technologies available today. Even powerful graphics cards can struggle with it. And in some scenes, the visual improvement may not be huge enough to justify the massive FPS loss. That's why most players still prefer standard ray tracing instead. Anti-aliasing. Have you ever noticed jagged edges on objects in games? That's called aliasing. It happens because everything on your screen is made of pixels. Anti-aliasing is a feature designed to smooth those rough edges. Without it, objects can look sharp and stair-stepped. With it enabled, edges appear much cleaner and more natural. The improvement is especially noticeable on fences, wires, buildings, and distant objects. Modern games often include several anti-aliasing methods, each with different performance costs. But in general, this setting helps make graphics look more polished. FSR. FSR stands for Fidelity FX Super Resolution. This is AMD's answer to DLSS. Just like DLSS, it renders the game at a lower resolution and then upscales it. The goal is the same: improve FPS without sacrificing too much image quality. The biggest advantage of FSR is compatibility. Unlike DLSS, which requires NVIDIA hardware, FSR works on both AMD and NVIDIA graphics cards. The image quality is generally good, although in some situations it may appear slightly softer compared to DLSS. But if your game supports FSR, it's usually a great option for extra performance. HDR. HDR stands for High Dynamic Range. This feature improves brightness, contrast, and color depth. Without HDR, bright areas can look washed out and dark areas can lose detail. But with HDR enabled, highlights become brighter while shadows retain more information. Colors also appear richer and more vibrant. This can make sunsets, explosions, neon lights, and dark environments look significantly better. However, HDR only works properly if your monitor or TV supports it. Without compatible hardware, you won't experience the full effect. Frame generation. Frame generation is designed to increase FPS even further. Normally, your graphics card renders every frame individually. With frame generation enabled, the system creates additional AI-generated frames between real ones. This can dramatically increase the FPS number you see on screen. Motion becomes much smoother, especially in demanding games. Sounds perfect, right? Not exactly. Because these extra frames are generated artificially, input latency can increase. This means your controls may feel slightly less responsive. For story-driven games, this usually isn't a problem. But for competitive shooters, many players prefer to keep frame generation disabled. Display sync. Display sync technologies help eliminate screen tearing. Screen tearing happens when your GPU and monitor are operating at different speeds. Part of one frame appears on the screen while another frame is still being displayed. The result is a visible horizontal tear across the image. Traditional V-Sync solves this problem by forcing the GPU to match the monitor's refresh rate, but this can introduce input lag. That's where newer technologies come in. NVIDIA's G-Sync and AMD's FreeSync allow the monitor to dynamically adjust its refresh rate to match the GPU. This keeps gameplay smooth while reducing latency. The result is a cleaner and more responsive gaming experience.